Welcome back to this series of circuit solving using the nodal analysis. We have mastered this technique by solving a multiple examples related to the basic circuit analysis of the simple independent sources, dependent sources, and supernodes using the nodal. Now let's have a look at more advanced technique, kind of a more advanced circuit basically, which contains a supernode and also a dependent source. Then how we can basically solve such kind of sources. So the approach remains simple. Okay, if you find a voltage source, identify whether it's a simple independent source or basically making a supernode or not. Okay, if it is making a supernode, identify that and write the equation for that supernode. So we can, if you look at this circuit, actually we need to find I naught and Ix, which is basically the current through 3 kilo ohm and 6 kilo ohm. Okay, so if we write the desired value equation for this one, so I naught is basically nothing, the current through 3 kilo ohm, what will be that? This voltage minus this voltage, right? So V1 minus V2 divided by 3k. And Ix is basically what? This is nothing, this is a current through 6 kilo ohm, that is basically what? V2 minus 0 divided by 6k. So in other words, if we find the value of V1 and V2, we can find basically I naught and Ix. So this is a purpose of the nodal analysis. So let's try to write the equation for these nodes. So looking at V1, we can find that basically V1 is a voltage source that is connected between this node and the ground. Okay, so it seems that the source is connected between the two nodes, but actually the second node is ground. So we can determine directly, like the value of V1 is basically what? V1 minus 0, which is basically is equal to 3 volt. So we can get the value of V1 directly from here. Now the second we are left with uh, V2. Okay, so let's write the equation for V2. What will be the equation for V2? Okay, so the currents, all currents leaving, like this current is leaving, this current is leaving, and this current is leaving. So current through 3 kilo ohm with the reference to V2. What will be that? V2 minus V1 divided by 3k, and V1 is basically what? 3 volt. Okay, so let's use that variable value here. So V2 minus 3 volt. Okay, plus through 6 kilo, what is that? V2 minus 0 divided by 6k, and lastly the dependent current source current, which is basically minus 2 times of Ix is equal to 0. So Ix is basically the control variable here. So we need to write up the control variable equation. We have already basically defined that thing here. So Ix is nothing, just V2 over 6k. So let's put that here. So V2 minus 3 divided by 3k, V2 over 6k, and minus 2 times of Ix. What is Ix? V2 over 6k. Okay, remember this is a typical, okay, standard procedure that if you get a control variable which is defining your dependent current source, so you need to write the equation for that and then put it in the main equation. Okay, so that you can eliminate that from our circuit. Now this is a simple equation with one variable only. Let's simplify that by multiplying with 6k. Okay, why 6k? Okay, the biggest here, the common lowest common multiplier of our values, okay, in the denominators. So 6k divided by 3k, we get 2. So 2 times of V2 minus 2 times of 3, 6. 6k, 6k cancelled, V2. 6k, 6k cancelled, minus 2v2 is equal to 0. So 2v2, V2 minus 2v2. This and this cancelled. So we have V2 basically is equal to 6 volt. Okay. So we know the value of V1, we know the value of V2. What is left? The left is nothing. We need to find the basically our desired I naught and Ix. So let's put up the values. Okay, to find I naught. What is I naught? V1. Okay, this equation minus V2. So V1 is 3, V2 is 6 divided by 3k. So 3 minus 6 will be minus 3, minus 3 divided by 3, 1. So that will be basically minus 1 milliampere. So what is Ix? This equation V2 over 6k. We have found the value of V2, that is 6 divided by 6. So that will be basically just simple 1 milliampere. So this way we can find basically the desired value. Thank you so much.